So this is question 5 from the AQA Core2 paper from June 2012. Diagram shows a sector OPQ of a circle with centre O. The radius of the circle is 18 meters and the angle POQ is 2 pi over 3. We're in radians, point to note. Find the length of the arc P to Q, that's this distance round the edge here, giving your answer as a multiple of pi. Must be a multiple of pi in the answer. Okay, as we're in radians, we need our radian formula. Arc length is equal to r theta. Plug numbers in. So r is 18. We're multiplying that by 2 pi over 3. Okay, straight away I can see that things are going to be cancelling. Good for us. 18 divided by 3 gives me 6. So that turns out to be 6 times 2, which is 12 pi. There's our answer as a multiple of pi. Very good. So far, let's just check the mark scheme. Mark scheme says arc equals r theta, m1. Just note that r theta seen or used. So at this point, if you don't use it, you're better off just write it down anyway because you get a mark for it. 18 times 2 pi over 3 gives us our 12 pi for 2 marks. Okay, second part of the question. So this time, the tangents to the circle at the point P and Q meet at the point T. So tangent here meets at the point T. And the angles are both right angles. So we've got nice right angle here, nice right angle here. Okay, for just 1 mark, so not much work to do. Angle PTQ is given as alpha. Find alpha in terms of pi. Okay, so what have we got? Well, it's a kite. It's a 4-sided shape. So altogether, the angles add up to 360. Or in other words, 2 pi radians. Okay, so we know that those two will be 180. So we can take those off straight away, or pi. So the remaining 2, we know that 2 pi over 3 radians plus alpha will add up to a whole radian. So I think we can see from there, 2/3 is going to be 1/3 makes up the whole one. So alpha is equal to 1/3 of a pi, or pi over 3 radians, okay, for 1 mark. Let's just check the mark scheme there. Yeah, just 1 mark, alpha equals 1/3 of pi. Find the area of the shaded region bounded by the arc and the 2 tangents. It's find the shaded area. Okay, so actually they've checked us already on can we find the arc length. We're going to need the area of the sector. So sector, the area of the sector is given by r squared theta over 2, which in our case we've got 18 squared over 2 times by theta, which is 2 pi over 3. Okay, working stuff out, cancelling stuff down. Thankfully it does cancel down. The 2's both cancel, so we're left with 18 squared over 3 pi. We're in Core 2, so we can use a calculator. On a calculator, that number comes out as 108 pi. Okay, so that's the area of the sector. Right, so that's that part done. 108 pi. Okay, next step, we need to do the area of the whole thing. So to do the area of the whole thing, I'm just going to split it right down the middle. Okay, and think about those 2 triangles. It looks particularly convenient that we've got that right angle there. We know that that one's 18 because we're halving the 2 angles. This angle is pi over 3. This angle is going to be, well, we've already worked that out. The whole thing, it was pi over 3 over 3. So this one's going to be pi over 6. Okay, we've got 2 angles. I wish I knew that length because then I just multiplied them together. That's going to be particularly convenient because base times height divided by 2, then because we've got 2 of them, we're just going to double anyway. So if we can get that length, the area of the kite will just be base times height of this triangle. Okay, so let's try and get that. What do we got? 2 sides, two angles, we're into the sine rule, which says A over sine A, capital A, is equal to B over sine capital B. That rearranges as A is equal to B sine A, capital A, over sine capital B. Labelling it up, what have we got here? We're going to have, this will be little a, so this will be big A, so this will be big B, and this will be little b. Okay, putting things in. A will be equal to 18 times by sine A, big A, pi over 3, all divided by sine B, which is pi over 6. Okay, working it through on a calculator, that whole thing, 18 sine, that all comes out as 31.17. What have we just worked out? We've just worked out that A is 31.17. Okay, area of the kite was base times height, so the area of the kite will be 18 times by 31.17, which is, on a calculator, 561.06. Okay, are we finished? No, because we were after the shaded region. To get the shaded region, one last step. It's the area of the whole kite, 561.06. Take away the area of the sector, that's our 108 pi. On a calculator again, that comes out as 221 point something. We're three significant figures. Yeah, three significant figures. So 221. Okay. Hopefully we're done. Let's check the mark scheme. Okay, the mark scheme is a little bit tricky for this one because there's so many different ways you can do it. But there's our pi over 3. We checked that already. Area of the sector. Again, write the formula down because you get points for it even if it goes wrong. Okay. In our case, we wrote it down and we used it. Half times 18 squared times 2 pi over 3, coming out as 108 pi. If you're happier in decimals, put decimals. Okay, except three significant figures or better because we need it for the rounding for the final answer. Okay, we've then got loads of different ways of working out the area of the kite. We were doing something like this way. Okay, we certainly came out with our 31 degrees. So there's our 108 pi. We were doing a version of this. There's our 31 degrees coming out. Some people may have left it as 18 root 3. Okay, we've got lots of or equivalent valid method and so on and so on and so on and so on. We can see down here, look, there's our 561 that we were using. Okay, we've still got more alternatives, but here we go for our final mark. This is our final 6 mark. 561, take away 108 pi, gives us 222 meters squared to three significant figures. So we should have checked that. A rounding error there. 222 meters squared to three significant figures. Your question to prove that you've watched this video and you've understood, this time please, could you write using index notation 1 over root x? What is 1 over root x in index notation? Thank you.